How long is 2 centimeters plus 3 centimeters? Well, if we have a look, we've got 2 centimeters there, and then another 3 centimeters, and we can say that it is 5 centimeters. Now, these are both of the same unit, so therefore we're only concerned about how many. 2 and 3 makes 5. The same goes for fractions. The denominators are the same here, so they're of the same type. So we're only concerned about the numerator. The numerator here is 2/5, and the numerator here is 1/5. So our whole and 2/5 are shaded. Our whole and 1/5 is shaded. So now, because the denominator is the same, we simply add the top values. 2 plus 1 is 3/5. Visually, for subtraction, we have 2 take away 1, which is 1/5. Now for division, we've got 2/5. How many times does 1/5 go into 2? Because the denominator is the same, we only consider the numerators. So it is 2 divided by 1, which equals 2. Now for multiplication, what's going on visually? Well, we're getting 2/5 of 1/5. So the 2/5 of 1/5 is just this area here. And there's 1, 2 out of 25. How long is 2 inches plus 3 centimeters? Well, firstly, we have to see that they are different units. So we cannot just add the numbers. We have to transform them to both being the same unit, either inches or centimeters. So here is 2 inches, and here is 3 centimeters. So now we'll transform the centimeters to inches, and we can see that, well, 2 inches plus 3 centimeters is approximately 3¼ inches. Now, the same applies for fractions with different denominators. We have to find a common denominator. To transform the fractions 3/4 and 2/3 into the same denominator, we multiply 2/3 by 4 divided by 4. I've chosen 4 as a number because of the opposite denominator being 4. Now we know that 4 divided by 4 is equal to 1. So whenever we multiply anything by 1, it doesn't change its value, it just changes its appearance. So when I multiply 3/4, I multiply that by 1, which is 3 divided by 3. And I've chosen the 3 here because it is the opposite denominator. Now, let's go through the steps. 2 4s are 8, 3 4s are 12, 3 3s are 9, 3 4s are 12. Visually, when I multiply this fraction, 2/3, by 4 divided by 4, it cuts the picture up into 4 parts. 1, 2, 3, 4. And if we look, we have the same area shaded, but they are cut up into smaller pieces. So we have 1, 2, 3, 4, 5, 6, 7, 8. That's where our 8 comes from. And we have a total of 12, makes up the whole, which is the denominator. So the same applies for multiplying 3/4 by 3 divided by 3. Remember, 3 divided by 3 is equal to 1, so we're not changing its value, we're changing how it looks. So I'm going to cut it up into 3 parts. 2 cuts, 1, 2, 3 parts. And if we count the shaded, 1, 2, 3, 4, 5, 6, 7, 8, 9, that's where our 9 comes from. And we have a total of 12 squares as the denominator. Adding the fractions 3/4 plus 2/3. Because the denominators are different, we've transformed it to 9/12 plus 8/12. So value is now 8 plus 9, which is 17 divided by 12. So to subtract 3/4, take away 2/3, we first need to transform to get a common denominator. And we have done that here, and 3/4 is equivalent to 9/12. 2/3 is 8/12. So the value of 9/12 take away 8/12 is 1/12. Visually, we have 9, 1, 2, 3, 4, 5, 6, 7, 8, 9 shaded 12ths, take away 1, 2, 3, 4, 5, 6, 7, 8 shaded 12ths, which leaves us with our 1/12. Okay, here dividing the fractions, 3/4 divided by 2/3. Well, we have to once again get a common denominator. Okay, and we have transformed it here. 3/4 is 9/12, and 2/3 is 8/12. We have 12 goes into 12 once, and 8 goes into 9. So we could write it as 9 divided by 8. And we know that, 3 divided by 1 equals 3. 4 divided by 1 equals 4. So 9 divided by 8 divided by 1, which equal 9 divided by 8. Now visually, what is the division doing? Well, the denominator is one whole and it's 12ths. So we're saying how many times does one whole go into one whole? That goes in once. We've got 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, divided by 1, 2, 3, 4, 5, 6, 7, 8. Hence we have our value and answer of 9/8. Multiplying fractions, 3/4 times by 2/3. Now, we have different denominators here, but the process of multiplying fractions is to multiply the denominators, which is 4 times 3 is 12, and the numerators 3 times 2 is 6. Now we can see that 4 times 3 gives us the denominator of our previous transformations. So the step of transforming the fractions in multiplication is contained within the first step. So we do not need to transform before we multiply fractions. Visually, when we get 3/4 of 2/3, this is what it looks like. The 3/4, and we're getting 3/4 of the 2/3 of the 2/3 that is shaded. So the overlap is 1, 2, 3, 4, 5, 6 out of the 12. Hence, we get our 6/12.